So we want to begin this last video talking about acid-base titrations. And like I said in the last video, in the previous video, this really is just a neutralization problem. It works exactly the same way. But the idea behind acid-base titrations, the book defines that as the process by which an acid of known concentration is added to a base of unknown concentration, or vice versa, and until a neutral pH is reached so as to determine the unknown concentration. And so the idea is that you've got some sort of indicator that whenever so you've got this acid, let's say, of a known concentration, and we're dripping that down into this flask here that contains a base of unknown concentration. And there's an indicator present, and so basically when the pH is neutral, in other words, when the base is neutralized, then it's going to change color, right? So it goes from this color to this color over here, and you know then that you've just had a neutralization reaction, right? You've added just enough base to fully just enough acid, sorry, to fully neutralize the base that's in this Erlenmeyer flask down on the bottom here. Now, when you do that, right, this measuring device allows you to see exactly how many milliliters or liters of the acid that you had to use in order to do that neutralization. And you know the concentration of that acid, so you know the molarity of that acid. And so when you put that together, you're able to basically do problems like we did previously with our neutralization example. So let's just do example 11.6, and I think you're going to see there's a lot of similarities between these. We have an NaOH solution in this example of unknown concentration, and it's titrated against a solution of HCl. Now, we've written these in the opposite order of how we had them in the problem in the previous example, because this is our acid here and this is our base, right? And they give us information about the acid because it was what was in the device here that allowed us to measure how many milliliters it took. It says it's a 1.29 molar solution of HCl, and it takes 12.11 milliliters to reach the end point, which means it took that many milliliters to neutralize the base, right? And so they want to know what is the concentration of the NaOH solution. Now, they did tell us here we know how many milliliters are in the flask down here, right? And they tell us that that value is 125.0 milliliters, right? So we should have everything that we need in order to figure out what the molarity, that's the final thing we're trying to figure out here, what the molarity is of that solution there, the concentration, right? Now we do need our balanced chemical equation, again, because we got to make sure that our stoichiometric coefficients in front of these guys are accurate. And so hopefully you're getting better at this point. The H and the OH are going to combine together to form the water. And then the salt is going to be what's left over. In this case, it's just Na and Cl, which literally is salt, right? If we do swap and drop with that, it just has a formula of NaCl. And this guy is actually already balanced, right? So there's nothing more that we have to do as far as balancing it. So we're going to do just like before. We're going to take the volume and the molarity from this to determine the number of moles of HCl. And when we solved for moles last time with molarity, we saw that the number of moles is equal to the molarity times the number of liters. And so we're going to do 1.29 molarity times 0.01211 liters, since we had to convert the milliliters to liters. And that's going to give us a value of 0.0156 moles. All right. So that's how much HCl it took to neutralize the sodium hydroxide, the NaOH over here. And so how many, if we're going to figure out the molarity of this guy, and they give us the volume of this guy, what do we need to calculate the molarity? Well, again, our molarity equation looks like this. So if they've given us the volume, which is the number of liters, we just need to calculate the number of moles, right? So how many moles of NaOH do we have if we have this many moles of HCl? Right? We're used to doing that in stoichiometry. And so actually this one's pretty straightforward if you do the conversion, since there's a one-to-one relationship between these. If we have this many moles of HCl, it means we also have that many moles of NaOH. So we're just going to go ahead and write that down here, 0.0156 moles of NaOH, right? You could convert it again, that's the portion of our where we go from, not grams of A, that's the portion where we go from moles of substance A to moles of substance B, right? You know how to do that. And then you're going to divide it by the number of liters of sodium hydroxide, which they told us was 125 milliliters. So we're going to change that to 0.1250 liters. And we punch that in our calculator to get 0.125 as the molarity for our NaOH solution. Right, so that was really straightforward and easy. It's not any different than what we did with neutralization, because what's actually happening when you put the acid into this flask down here and it changes colors like this, it's because we neutralized that base. And so it's just a neutralization problem. So nothing new if you understood what we did in the previous example. Okay. Well, the last thing I want to talk about, something that's a really common concept when you're using acids and bases, is that you'll buy this stuff in the store in concentrated form, but then you need to use it at a different concentration. So how do we change the concentration of the solution? And so that's what this last section is all about, diluting acids and bases. In other words, if we're diluting it, we need to figure out how much water we need to add in order to create the new concentration that we need in the lab, right? And so the example that we have here is we've got concentrated hydrochloric acid that's bought from a chemical supply house, and it's a 12.4 molar solution of HCl. So initially our HCl is 12.4 molarity, right? If a chemist needs 250 milliliters of a 2.5 molar solution, so this is where we start, right? This is the original, as it is in the container that we buy. But what we need 250 milliliters of a 2.5 molar solution. All right, we need 250 milliliters of that. So the question is, how should she prepare it? So in other words, what you're going to do is you're going to pour out a certain amount of this original solution into a container, and you're going to, so you got to figure out how much of that original container you need to pour out, and then you're going to add enough water to have 250 milliliters, all right? And so here's what I want you to get. What you're actually trying to calculate is how many moles of this HCl are we pouring into our container, because there's a certain number of moles that will be in this solution here, right? If we know the molarity of something and we know the volume of it, then we can calculate, there are a certain number of moles that are associated with that. And because the number of moles we're pouring out on this side has to equal the number of moles that's in the final solution at the end, when you solve the molarity equation for moles, we've already seen you get this, right? Moles times the molarity times the number of liters equals the number of moles. Well, the same number of moles need to be poured out of this solution that are going to end up in this solution here. And so what that means is that since the number of moles is constant in both cases, then we can simply say, whenever we're doing this conversion, since the number of moles is equal to molarity times liters, we can just say the molarity and the number of liters on the original side needs to equal the molarity and the number of liters on the right side, right, with the amount that we're trying to make. And so we could just plug in the values that we know and solve for the unknown, and that tells us what the volume is of this stuff that we need to pour out. All right. I hope that L's not confusing you here. It really is volume, right? It's the molarity of the first molarity, and the first volume has to equal the second molarity and the second volume. And but I put the L there just to remind us that we're using liters for this equation. All right. So let's go ahead and just plug in what we know, right? Our original was 12.4 M. And we don't know what the volume is, so we got to solve for that. And our second one is 2.5 M. And we normally would convert this to liters. So let's go ahead and do that and make it 0.250 liters instead of 250 milliliters. If we solve for V, right, what do we get? Well, we're going to, we take the 2.5 times the 0.250 and we divide that by 12.4 and to get a final value of 0.0504 liters. And so what does that mean? It means that in order to create this solution right here, a 2.5 molar solution of 250 milliliters, we're going to pour out 0.0504 liters of this solution, and we're going to add enough water to equal 250 milliliters. All right? Pretty simple. It's just, you really just need to know this equation right here when you're doing dilutions. You plug the values into that, and it's pretty straightforward. Okay? Well, that's it for this chapter. If you have any questions, as always, reach out to me, and I will see you guys before long.